So here's a problem that goes over electric charge and Coulomb's law. So let's say you want to get a rough idea of the amount of charge a shirt gets from being in the dryer. You take two empty aluminum cans, each can is 100 grams, and hang them from two ends of a string. The string is draped over a nail, and the cans hang 20 centimeters below the nail. You take a shirt from the dryer and touch it on the cans. The cans move apart and are 10 degrees from the vertical. Assume equal amounts of charge was transferred. What is the amount of charge on each can? Okay, so to kind of set this up, we've got a nail, like in a wall, string hanging down, and we've got two soda cans hanging from the end of the string. And then we grab a shirt from the dryer that we forgot to put some fabric softener, so it's got some charge, and we just touch it to the cans. And the cans are aluminum, so there's direct transfer of charge from the t-shirt to the cans. Now, each can gets the same type of charge, and so since the cans, let's say they both get they have a negative charge. Because they both have like charges, the two cans will repel. So that's why they move apart. So kind of the final kind of position. Got a can, and they're hanging in this angle. This angle's 10 degrees, and so is this angle. And each one has, we'll call this Q1 and Q2. So kind of the first step is, as in mechanics, is to draw your free body diagram. So I'll draw my cans here. And so we've got force of gravity, your tension force from the string, and then I've drawn two here. So we've got the electric force of can 1 and can 2. So right now we're in equilibrium. So remember, with force equals ma, we don't have an acceleration, so we have a balance of forces. So I'm going to first write our balance of forces in the y direction. So we have the tension force in the y. So remember, here's our coordinate system. I'm going to first get my y forces. So with the tension force, part of that force is in the y direction, part of it's in the x direction. So the part of it that's in the y direction is positive, and then we have minus force of gravity. Gravity's pointing downward, and that's equal to 0. Now Fty, so then tension force in the y direction is equal to gravity force, which is equal to the mass of the can times g. And I'm going to work this problem, everything in SI units, so kilograms, meters per second squared, newtons. So g, as you remember, is 9.8 meters per second squared. And the mass of the can is 100 grams, which is also 0.1 kilograms. And so 0.1 times 9.8. So we get that the force and tension force in the y direction is 0.98 newtons. Okay, so now in the x direction, we have force of can 1, 2, minus, the tension force is in the negative x direction, so minus Ftx is equal to 0. So I know that the electric repulsion force, F12, is equal to my tension force in the x direction. And I can find this guy from trig. So here's like my Ft. And I've already known that in the y direction it's 0.98. I'm trying to find this guy, Ftx. Another thing I know is this angle. So I know that this angle is 10 degrees, which makes this angle also 10 degrees from symmetry. So ftx over fty is equal to tan of 10. So our tan of 10 degrees equals opposite of our hypotenuse. So then if I'm doing the math, you should get that the force 1 on 2 is going to be 0.173 newtons. Now what is this force? Remember Coulomb's law. So Coulomb's law says that the force between two particles is equal to K Q1 Q2 over R squared. Now these two are the same, so I can simplify this to K Q squared over R squared. I know that my force is 0.173. K is 9 times 10 to the 9th. Q squared over R squared. Now my R is the distance between can 1 and can 2. And I know that this distance here is 20 centimeters. So again, I can use trig to find this distance, and then I can multiply that by 2. So using trig, this is 0.2 meters, converting centimeters to meters. So I'll draw this out. We've got similar triangle. And I know that this here is 10 degrees. I know that this is 0.2 meters. So then I'm going to find that this is 0.035. So then my R will be double that because it's this entire distance. So my R will be 0.0705 meters. So then I'll get my Q. My final answer, charge on each can, is 3.1 times 10 to the negative 7th coulombs. Oops. So that's the amount of charge in each can. So as you saw, we kind of used some concepts from the past, like our free body diagram, balance of forces, and we kind of add this new thing of applying Coulomb's law with charges. Thanks for watching.